Hello friends, my name is Manshu Bharadwaj and I have brought a new series of video on geophysical logging and its interpretation on Python. So Python provides basic packages that could be very useful in geophysical log visualization and creating some machine learning algorithm for the interpretation of geophysical log. So geophysical logging is used in the industry for many purposes. In oil and gas industry, it is a tool to determine the fluid property and fluid modeling, which is a part of reservoir modeling uh, of the subsurface, and it could give you the water saturation, hydrocarbon saturation, formation, water resistivity. So it is used for many purposes. It is used for having a better assessment about the porosity of the formation. So there are many porosity logs that that is that has a direct relationship with with the porosity of the formation, and that could directly be converted into a porosity using some empirical formulas. For example, the density porosity or neutron porosity, although these are not the actual porosity of the formation, but these logs has a direct relationship with that. So I will uh, I will be doing many things with uh, using geophysical logging data. So first of all, I will uh, I will demonstrate how to develop a machine learning algorithm to determine the lithology from the geophysical log. So I'm using the Kansas oil field data for and there are many open source database available for Kansas oil field, and you can download the geophysical logging data. So in this video, uh, my discussion will be based on two things. One is on the visualization part, means how to visualize geophysical logs, how to how to write codes to have a better visualization for geophysical logs. And my second part of video will demonstrate how to develop machine learning algorithm for determining the lithology from geophysical log. So let us start the video. Let us start. Uh, so I'm going to share my screen here. So again, I'm using the Jupyter notebook. So everything, because the Jupyter notebook is very convenient to show the code as well as the visualization part, where you can see the result immediately. So it is a good tool for learning. So first of all, let me explain. Let me explain which kind of log I'm using I'm going to use the for lithology interpretation. So basically, I will be using gamma ray log because natural gamma ray log is a very effective tool for shale volume calculation as well as and determining the shale lithology, isolating the shale lithology from other type kind of lithologies. So it differentiate shale from sandstone. It differentiate shale from dolomite or limestone very effectively. So this tool is very useful. So I have taken into account for lithology interpretation. Then the second tool I am using is the density porosity tool, which is nothing but porosity calculated from the density law. So there is a formula that a very easy formula from which you can calculate the density porosity from density log. Uh, I think you would have been studied those formula in your college days. Uh, if you have uh, gone through a very intensive geophysical course, attended some college courses, so you would be aware of the density porosity, how to determine density porosity and the neutron porosity from the neutron logs. So these two logs are widely useful in the are widely used in industry. So for density porosity, we have cesium 160 or sorry, we have cesium source or the cobalt 60 source, and it is not a natural source log. So we bombard the gamma ray to the formation, and we record the response from the formation. So basically, when you bombard the gamma ray to the formation, three kind of reaction happen. One is the pair production, other is the Compton scattering, and the photoelectric effect or the photo. So three kinds of phenomena happens while you bombard gamma ray on to the formation. So these three phenomena depending upon the source of the source strength means uh, for different energy level different phenomena may occur. So, for example, for photoelectric factor, you require 0.662 MeV of gamma ray. So there is a probability distribution function that tells you that whether a phenomena would be a photoelectric phenomena or Compton scattering or some other thing. So photoelectric factor log or the photoelectric formation log I have also taken into account, which is a new tool or which is also called the lithodensity tool. So this photoelectric factor is measured in barns per second. So this tool is very useful while determining the lithology because the photoelectric factor does not depend on the fluid present in the formation. So unlike density or neutron porosity log, which are highly affected by the formation fluid, photoelectric factor, on the other hand, is a different kind of log which is unaffected with the formation fluid and which directly associated with the matrix property of the rock, the matrix of the rock, the hard part of the rock. So it is directly related to the material property of the rock. So we can determine the lithology from photoelectric factor very efficiently. So let us start with the visualization part uh, of geophysical logging. How can we visualize on on Python? So I have already prepared few codes so that because video length would be very long if I go one by one for every coding. So how I develop the code. So it is better to have a already prepared code. For machine learning, we will be doing. Uh, I will explain by coding. So, but in visualization part, I have already prepared a code. So I will explain how I prepared the code, and then you can see this file. So first of all, we have a track plotting, so we can develop this on Python also. So this is the database file that I have created. So this is the log file that a field record, and after few editing, and this is the log header. So this explains the which log means it explains the name of the log. So this header, for example, uh, The FEAP log is a shallow formation factor, and the NPRL log represent the limestone neutron porosity. Similarly, CLDC represent the density caliper. So there are various logs available in the in this file, and I have developed a track plotting. So you can see this is a track plotting of geophysical log, which is very convenient to visualize the entire well. So this kind of plotting you are aware of because you will be plotting this on various software like Wellcat or other Petrel and other softwares. So this law, so you can also plot this on Python also. So this is another example in which on track 1 I have taken the porosity log, density porosity and neutron porosity. On the second track I have shown the electrical logs, so deep resistivity and the shallow resistivity, 40 inch, 60 inch and the deep one. And on the third track I have used the sonic log. So I have given the sonic log. So you can develop this kind of visualization. So how I'm going to explain how I developed this code. So I have created a function, but the most important part of this function is the plotting. So you can have, if you are aware with the matplotlib plotting, so I've used simply the matplotlib to develop this track plotting. So in this plotting on axis, I have created various axes, and the important part is the twinny. It means you can have multiple axes on each plot using a function called twinny. So you can have multiple. So you see here, uh, I have this twinny, this one. So this create. So using this function, you can create multiple axes. So I'm not diving deep into the part of track plotting. So you can develop by yourself. Uh, I have given the code on the GitHub profile, so you can visit the code and you can modify this code according to your convenience. So I have created a function here in which you can give the log names and also the depth range. From depth range means which part which from which depth to from means you can set a depth window, and also for visualization, because when you plot the entire log of the well, then you cannot visualize log uh, efficiently and effectively. So you want to zoom some part of the log, zoom some part of the log. So that is why you can give the depth window. Again you can set the range also. So I have given few flexibility. From right here you can set the range of the track plotting. So this is how I developed the code for track plotting. So another thing, log visualization part. So this was the track plotting and track visualization of geophysical log. Another thing I developed here is uh, some of the, yeah. So this one. Another thing is the lithology plotting. So lithology plotting, for you can create hatch here and also the color code for different lithology. So I have around 13 kind of lithology, 12 13 lithology from 0 to 12. So there are halite, gypsum, dolomite, dolomitic limestone. So for every lithology, you can create hatch as you do so in on surface plotting. So these are the hatches and the color, different colors. So as per your convenience, you can have different colors and different hatching. So hatching you can use X or this slash and plus, and these symbols you can use for hatching. So for more information, you can visit the matplotlib documentation, and you will find how to do hatch and all other things. So in this way, I have created a hatch plot. So this is the code for every log. I have every color code and hash I have prepared for different lithologies. So I've used this code for representing the interpreted lithology from machine learning. So in the machine learning part, uh, so let us start the machine learning, writing the machine learning algorithm. So for that, let us start with a blank window, and we can do the machine learning algorithm. So just start the machine learning algorithm here. Wait, one, just a second. Let me adjust my camera first because it's not stable. So let us start the machine learning algorithm. So three basic. So for machine learning, you need not to require any advanced tool. You can use basic tools of Python, basic tools of Python available freely for every users. Like you have to use pandas for databases and other. Uh, you can also use NumPy for different kind of array and different type of calculation based on array. And for plotting, you import matplotlib. There is another a very useful tool for uh, plotting is the seaborn. So you can also import seaborn because this gives you a better graphics provides. So these four tools you can import, and now I will show you how to use these tools to visualize. So for machine learning, the very first part of any machine learning is particularly for supervised machine learning is to prepare a training data set, and it is the most painful part of your machine learning algorithm. So you have to prepare a training data set first. So I have already prepared a training data set for cancer soil field because it depends upon the uh, geology that you are dealing with. Means it depends upon the geology of the area, which varies places to places, and also the tools also you will not find a because different tools are used for different areas. So for every particular area and for every particular geophysical logging tool, you have to prepare particularly a training data set. You cannot use a universal file for every machine learning for every for uh, predicting the lithology of every geophysical log. So be aware. if you are working in a particular area using a geophysical logging tool, so you have to use that tool. You have to prepare the training data file for that particular area and for that particular tool. So let us start. Let us import the load the data set. So in a data frame. So read CSV PD read CSV file reads the data set. So I have saved this the my training data set that I have prepared in a dataset.csv file. So just import this file and see the header file of this data. See the few records of this data. So you can see here we have gamma ray, neutron porosity, density porosity, and formation factor. And corresponding you will find the pick or the true column. So this is nothing but the lithology code, corresponding lithology code. So 7 code is represent some kind of lithology. So I'm just loading the lithology code. So lith file, I'm going to code the. I have stored the lithology codes for different uh, different lithology. So just so these file you have to prepare in advance. I have uh, prepared the lithology code. You can also directly write the lithology code. No need to have a lithology code, but for my convenience and I have make it on a separate file. You can do it mm, according to your convenience. So let us see. So here you can see that the 7 is corresponding to Cherty Dolomite and 3 is corresponding to gypsum. So I want to have this lithology uh, here. So have to make another column that represent the lithology, not the lithology code. So I am going to merge the file. So for that, use merge because there are various database function that database pandas database provides you merging of many databases. So you can merge the database merge. So let us merge lith. So I am going to merge X and lith databases. So for that I am using the function merge, and based on which column I am going to merge. So you can see two columns are common in both the files. So based on two, I am going to merge the database file. So two, and let's see whether the merging happens correctly or not. So you can see now both the file has been merged, and now you can see the corresponding lithology for the log. So this is the training data set that is required for machine learning algorithm. Now, uh, if you want to have some visualization, box plot or something like I have created already created visualization of these blocks. So you can visit. So in this file you can see. So you can use pair plot. So you can use pair plot. So it gives you a matrix plot. So this is the gamma ray, and you have the corresponding plot of neutron porosity. So it gives you a matrix plot, and you can visualize the different cross plots or different scatter plot and see which lithology which combination of logs separate which lithologies. So here you can see that the gamma ray is able to isolate this shell. Green one is the shell and the rest is the other lithology. So this gamma ray is useful for isolating the shell. So in this way you can use the visualization. Another very useful plot is the box plot. So let us do the block box plot. So I'm using the SNS function to to see the box plot. So first uh, set the figure size. So fig size I'm setting it is 8 and 12. You can set according to the accordingly so that better visualization could be obtained, and then you just box plot. So you can use the function box plot function. So on y-axis you are going to give the lithology. So x, where is the lithology? Which column? Lithology column. So lithology, then x, x, and I am going to show you the PEF plot. Okay, and what is data and orient should be horizontal. So its orientation should be horizontal. Orient should be horizontal. So let us plot this, and you have the box plot. So you can see many of the lithologies can be uh, separated with other lithologies. For example, for coal, sandstone, you have a different range. So you can see this log is very useful in isolating the lithology. But one problem is the shale lithology. The shale lithology overlaps with other lithologies. You can see although dolomite, chalky limestone, and dolomitic limestone are well separated, chert are well separated, gypsum is well, but shale has overlapping property. That is why gamma ray is useful here. So gamma ray will be able to isolate shell from other lithology. So now let us start the machine learning algorithm. So you can have different visualization tool. You can also plot the histogram also. So if you want to see the histogram, you can this plot. You can use this plot and just see the histogram. So you can use this also. You can see the histogram, and also if you want to see the this part of mythology is there. Sorry, you can assign the color also. Okay, for the clear, you can use the Instagram. So now let us Now you can see here in the database, in my database, uh, the proportion of various lithology, means various lithology are not in proportion with other lithologies. Some lithologies are highly abundant in the law, and some lithologies are very rarely found in the well. So in this training data set, and that is why to make all the lithology in proportion, I am going to use stratified uh, sample. So so for stratified sampling, you have to, there are a skill learn. So first we have to go for stratified sampling, and second thing, I'm using uh, random forest tree method for machine learning. It's a very useful tool, and it is highly suitable for determining lithology from geophysical logs. So that is why I'm using the random forest method for machine learning. So in model selection, you will get the stratified sampling. So let us start the model selection from sklearn.model selection, import stratified. You can use also random sampling, but again, all the lithology are present in my training dataset are not in proportion, and that is why I am going for stratified sampling. So stratified shuffle split. So and also we need to, and we have to, you can also go for cross validation, but I'm using only a train and test split samples for, so only two. I'm going to split the dataset into two parts only, the training and the testing part. But you can have a better model selection. Some file is missing. Let's learn the model selection. Some mistake has happened. So, some problem I am getting here. Uh, some file is missing perhaps. Anyway, so here don't use this. You can also, train test split, then go for. So I'm just dividing the data set into two parts, train and test part, and train test split. I don't know what problem some file is missing on the system. So I have to reinstall and those files. That will take time. So since I do not have time here, so let us start without stratified sampling. But I recommend to go for a stratified sampling. So your train and test data set has been prepared. So, so using the function train test split, you can create a train and training data set. So let us visualize the train dataset, you can determine the shape of this file. So this is train and this is test. So it has been divided into the ratio of this ratio 0.3. So you have to provide the test size. So I'm just maintaining ratio of 70/30. You can give a different ratio. So uh, let us start uh, now. Now we have the training and test dataset. So I'm just dropping the last column of training data because we also have the lithology file. So there's no need of having a lithology file. So let us train X train. Okay. So use gr here PSPL and PSL. So similarly, also do it for test file also. So TEST test. So you have the training and testing dataset. Now you have to scale the dataset because different before feeding into the machine learning algorithm, you have to scale the dataset between -1 to 1. So import from sklearn, just import preprocessing from sklearn dot preprocessing import standard scaler in order to scale the dataset. So let us scale the dataset between 0 and 1. So standard scaler. So let us scale the dataset. So train X scale dot fit transform train X. Similarly, scale the test dataset scale dot fit transform test X. So you have scaled the dataset. Let us check whether scaling has been done properly or not. So you can see that the dataset is now in between -1 to 1. Mm. So now they have been properly scaled. So now I'm going to import the random forest classifier from sklearn dot ensemble. So it's a kind of ensemble algorithm. That is why it is there in the package ensemble. So random forest classifier. Let us import this classifier to classify for the. So let us take a function random forest classifier. Now just train the model. So I am going to fit the model with training dataset and train and the corresponding target. So it is there that train the corresponding target is true. It is the numeric form. So just fit the model. So now the model has been fit. Now whether your classification is done properly or not, there's one way to visualize it, that is using a confusion matrix. So I'm going to import confusion matrix here. So plot confusion matrix function will plot the confusion matrix here. So let us import this and then plot the confusion matrix. Confusion matrix. So you can see whether your data set is properly mm, classified or not. So test X and the testing dataset can plot the confusion matrix. So you can see the confusion matrix here. So in the diagonal you can see all are properly classified and the cross diagonal elements are zero mostly. Only this one is the 5. So these are the misclassified data. Means true level is different and the predicted level is different. All other things are well classified. So based on the testing data set, you can say that your machine learning algorithm is quite well in predicting the lithology. So now you also want to know the accuracy of your model. So from sklearn dot metrics, this is another metrics that will tell you the accuracy, but most important metrics is the confusion matrix. In case of classification, in case of regression, you go for accuracy and everything. But you can also see the accuracy score if you want to just print the accuracy score. So test true and first predict the you have to predict mm, so model dot predict, you can use this function to predict the lithology from geophysical log. So test X is the testing data. So you can predict this and use this here. Predict to know the accuracy. So you are getting 99.63% accuracy, which is a quite good accuracy score. Now let us test it on another geophysical data. So let us import a geophysical file, log file. And I have saved it in gph.csv. So this is the first 5 row of the dataset. So since we have developed machine learning algorithm based on only 4 logs, so just import the four logs. So is what? So you have used these four logs, gamma ray. So you just select this in the same sequence. So EEF log is not funny, actually it is PE. So you have these four logs. Now just you have to edit this log first. So def1 dot replace, because you have minus 99 point this two, you have to replace this with with nan function, and then drop in place 2 in place 2. So now you can see this has been replaced to nan. Now drop the nan file. So df1 drop na, you can drop the na file. So here I am going to, instead of dropping, you can also use the fill na method, but I am going to drop this, and in place is 2. In place 2 means will be dropped. So now you can see that all the nan data has been dropped. Now your file is ready for prediction. So let us again, first you have to scale it. So scale D user. So you have scale that it transform, then df1. Now your database has been scaled and you can directly use for prediction. So let us predict. So predicted value will be this predicted value will be model dot predict, and now apply this scale D. So now you have predicted result. You can make a column here, predicted lithology and predicted. So now you can see the predicted one. Now you want to have, so these are the in the form of lithology code. We want to have lithology, so let us merge it with the lithology file. So df1 is equal to df1 dot merge with lith file on. So left on will be predicted value, predicted lithology, and right on will be 2. Now you have merged the dataset, you will be getting the corresponding lithology. So this is the predicted result. So this is how we have created the machine learning file and predicted the lithology. So this is all about how you can create. This is all about how you can create the machine learning, how build the machine learning algorithm and predict the lithology from geophysical log. So in the next video, I will my camera is not working. Let me correct. Why my camera is not working? So, what are the prompts, guys? मुझे prompt दो. Prompt दो. पता नहीं है क्या पूछ. So yeah, now it is working. So this is all about building the machine learning algorithm on Python with some basic tools that is available in the form of open source packages. sklearn is an open source package that you can use. There are various machine learning algorithm available in sklearn package. For example, random forest method, and you have the support vector machine neural network. You can use all such algorithm here to develop a machine learning algorithm for determining the lithology from geophysical logs, and you can save your valuable time, because once you have created the algorithm, you can save the machine learning file and use it to interpret lithology from other geophysical logs, so it will save your valuable time. So I'm going to stop here sharing my file. So this is all about developing a machine learning algorithm. In the subsequent video, I will show you how to determine the formation water resistivity from SP log and the water saturation using Archie's formula, and how to determine various parameters for reservoir modeling. So I end here. Thank you very much for watching my video. Please visit on my channel regularly for more and more videos. Thank you very much.